Hello students, today I want to talk to you about data types in Java. So first, the story of data types. Uh, Typically what happens is that computer programs work by creating slots for the data that our program is going to use inside the RAM, and of course recording the program instructions. We are only going to talk about here those slots in the RAM, those locations in the RAM where we are going to place some data either entered by the keyboard or hard-coded. Okay? So what is data? Data can be your numbers. Data could be your text, and data could be values like true, false, yes or no. Somebody asked you a question and they say you can only answer this question yes or no. That's the another kind of data, yes or no, which in computer science is called a boolean data. And there are some special data in object-oriented programming languages like Java, which are called objects. Okay, so we're going to talk about all of these one by one. Okay, so let's talk about numbers first. Numbers. Well, numbers could be whole number, and numbers could be, I'm just going to call nums for short, that can contain fractions. Of course, you know these from math, but while math is done on the paper, computer's RAM is not a paper. We actually need to make number come alive, and that requires some data management. So let's talk about the whole numbers first. Whole numbers. Whole numbers are the numbers that cannot contain fraction when we store them inside the computer. Those are called integral type. Integral type. And there are different sizes in bytes inside the RAM. These types are short, something called an int, short for integer, another one called long, and generally this is 2 bytes, int is 4 bytes, and long is 8 bytes. A byte is, 1 byte is 8 bit, you know that. Okay. Obviously, because of different bytes, this can store only up to 32,767 on the plus or minus side. This can store more, and this can store even bigger. All right? Okay. Anyway, there are other integral types in the sense that they are stored inside computer as integers. One of them is char character. Okay? character. I'll talk about that a little bit later. Okay. Let's go back to whole numbers. The declaration of whole numbers in Java is like this. Int, one of them anyway, int like age. So first you have the data type and the variable name. When you do this, what Java does, it creates a box in the RAM. The box is called an age. This is the name of the box. And inside it, at that point, we don't know what is in there. For all practical purposes, this line will simply create a box. For us, that's just a garbage. Okay? And Java requires that all variables before use should have a value. You can declare them without a value, but when you use them in any shape or form, they must have value. And that's called initialization. That's actually called putting a value. Initialization would be that you can just put some value in there. There's an important thing about the integer data type which applies to short, int, and long, applies even to characters. And that is that integral type cannot contain fractions. Of course, I've said that before. But there's more to it. Integral types are ordinal. What is the meaning of ordinal? They have a pre-described fixed order. Fixed order. What is that order? If I have a number 3, I know that predecessor to 3 has got to be 2. It cannot be anything else. And the successor to 3 has got to be 4. It cannot be anything else. So predecessor to 3, successor to 3. That is fixed. You do not have that luxury with floating point numbers. For example, if you have a number called 3.4, we can never be sure that predecessor to that is 3.3 or 3.301, and successor to that could be 3.41, 3.405, anything. So there is no uniqueness in the floating point number as far as their predecessor or successor are concerned. So floating point are not the ordinal. Integer types are ordinal. Okay? Very important. This is a very important fact in computer science, actually. The other thing is that when you do any arithmetic operations on ordinals, the result must be an ordinal. So any arithmetical operations using only ordinals can only have an ordinal result. And the most confusing part of that is that if you divide an ordinal by another ordinal, hey, you cannot get a fractional result. You'll get only a whole number. We'll talk about that a little bit later. Okay? Next, I want to talk about numbers that can contain fractions. Okay? The generic name for them is floating point numbers. Alright? And in Java, these are float, which is 4 bytes, is double, which is 8 bytes, and this okay, we'll deal with these two only for the time being. Since double is 8 bytes, it has a precision, and float is 4 bytes, so double has a precision twice the float. Higher precision allows double to store floating point numbers more precisely. A little bit later we'll show you that floating point numbers in Java or any other language for that matter can never be, at least some of them, can never be stored exactly with the precision with which you think about them in your mind actually. Okay? It's very important to know that. Declaration of floating point numbers is done like this. I can say double GPA, and when that happens, you created a memory location called GPA, and of course we have not initialized it, so with this statement you just have garbage in there. Okay, so that's the floating point numbers. So example of floating point number could be GPA, that's say 3.4, etc., etc. Okay. There's one interesting integral type in Java called, in Java the name is char, real world name is character, okay, which is 2 bytes, and since 2 bytes is 2 to the power, 1 byte is 8 bits, so you can contain up to 2 to the power 16 different characters in char data type, which comes out to be 65,536 characters. And the declaration is something like this. We say char ch equal to, actually I'm not going to talk about initialization right now, so let's not worry about that, this. And when you do that, you create a memory location ch, ch, and of course since we didn't initialize it, the value will be garbage when you have this declaration. Okay. Boolean types are that can contain only true or false values. Okay. They're not comparable. True value is not less than or greater than false. They are two discrete quantum states like values. You will declare them like this, the keyword boolean, and let's say today is Friday. So if I say is Friday, so you'll create a memory location which is called is Friday, but notice there's no equal sign, no initialization, so I just have at that point garbage in there. That's your Boolean data type. Then we have something called Java objects. These are pre-built by Java for us, and frankly speaking, life would be pretty miserable without them. But they not only store some data like either text, numbers, floating point numbers, boolean in them, but they also have some intelligence built into them, some methods. And there will be a lot of work we will be doing on that, but the most important in that is string, where S is the uppercase. Java is a case-sensitive language, so you cannot forget which data is lowercase, which is uppercase. All the ones that we talked so far are spelled in lowercase, string is spelled in uppercase. And its declaration will be something like that, string name, which means we intend to store somebody's name in there. Here's the interesting point. In case of string, you don't create a garbage. Java allows you to declare a variable with this name, but at that point it creates a zero-length string in there. So this one is already initialized, okay? So that's a nice little gift we get from Java, okay? When we start to take input from the keyboard, we'll talk about other objects, other types that Java creates for us. Actually, we have to write a code to create, but they are available in Java. Arrays are another one, and so on. Okay? You may ask the question, why data types? Why not just have one type and be able to store anything in it? Well, surprisingly, some languages actually do that. JavaScript does that for you. You can declare a var variable there, and you can store anything in there. There is a huge problem with that, however. Each data type has different sizes. Int 2 bytes, double 8 bytes. The string turns out to be more like at least 32 bytes, character 2 bytes. If we had same data type for all the data, we'll have to allow that memory location to expand or contract based on the data type. That's not a very efficient operation. So data types are there because allows storage efficiency, and it provides some safety for our data. If I have a social security number stored as a string, I want to make sure it stays as a string because I don't want to do math on it. Okay? If I didn't have data type, accidentally or purposely I can end up doing math on it, which could be in certain operation that could be a complete disaster actually. So allows efficiency, allows safety, which is called type safety. And there are many other efficiency related applications. For example, at some point you know in more detail that when you do math inside the computer on integers, that's a lot more efficient than doing the math on floating point numbers. So if you have certain integers and you don't really need a floating point mathematics on them, well, only the integer math, well, that's going to be very much more efficient. So for example, adding 3 plus 5 is much faster than adding 3.0 plus 5.0. So if there are 3 people in one room, 5 people in another room, and all of them assemble in one room, you want to say there are 8 people. Doing it this way, representing them 3 people and 5 people as integer, is much more efficient than representing them as 3.0 people or 5.0 people. These are some of the reasons why we have data types in Java. Okay. So in summary, all I've done here is given you the data type, which are integer, floating point, character, boolean, and objects. Object, the string is the most important one. Okay. And then next time I will discuss that once you have declared a variable or a data type, how to initialize that, and if you have a value to put in there, how to do that, and what are the legal operations in assigning values and what are the illegal operations. Of course, a good editor like Eclipse will tell you what is illegal or what is illegal. Thank you.